And now in this lecture we'll answer on two questions. In the first question, we find out the value of line segment X that is inside rectangle ABCD. In the second question, we'll find out the area of the green shape that is inside a semicircle. So we start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have this circle, and we know that the tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle is the tangent that we are looking for. So it is equal to x, and we have to find out the value of x. And finally, the tangent from point D to this circle, it is equal to 35 units in its length. Our mission is to find out the value of x, that is the tangent from point C to this circle. Okay, so first of all, we define the center of this circle as O. We define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of tangent D from to this circle as F. We define the point of tendency of the tangent from point C to this circle as H. And we define the point of tendency of the tangent from point B to this circle as T. We join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle. We define the radius of this circle as R, so OE equals to R. And we have the radius OE that is drawn to the point of tendency, and according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency, and we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, tangent AB will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 1. We can implement rule number 1 in our drawing. Why? Because in our drawing we have tangent the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle. It is equal to R. We have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Likewise, we join points O and H together by a straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of this circle that is equal to R, and we have the radius OH that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. And finally, we join points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself. Therefore, OT is the radius of the circle that is equal to R, and we have the radius OT that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. In the next step, we'll join points A and O together by a straight line. By joining points A and O, we created here the right triangle, triangle AOE. We'll implement the Pythagoras theorem on the right triangle, triangle AOE. In the right joint triangle, triangle AOE, by PT is a relation for Pythagoras theorem. So in the right triangle, triangle AOE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AO square equals to OE square plus AE square. Repeat again, in the right joint triangle, triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. So AO square equals to OE square. OE is R, therefore OE square is R square plus AE square. AE equals to 33 units according to what is given as the question, therefore AE square is 33 square. So, in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we'll join points O and B together by a straight line. So we created here the right triangle PTO. We will implement the Pythagoras theorem on the right yellow triangle TOB. The right yellow triangle, triangle TOB, by PT BO square equals to OT square plus TB square. Repeat again, in the right yellow triangle, triangle TOB, BO square equals to OT square plus TB square. So BO square equals to OT square. OT is R, therefore OT square is R square plus TB square. TB equals to 85 units according to what is given as the question, therefore TB square is 85 square. In conclusion, we found out that according to equation number 2, BO squared equals to R squared plus 85 squared. In the next step, we'll join points C and O together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle edge OC. According to the Pythagoras theorem, on the right orange triangle edge OC, CO squared equals to edge O squared plus edge C squared. Repeat again, the right orange triangle edge OC, CO squared equals to edge O squared plus edge C squared. So CO squared equals to edge O squared. Edge O equals to R, therefore edge O squared is R squared plus edge C squared. Edge C equals to X, that is the line segment that we are looking for, so edge C squared is X squared. So in conclusion, we found out that according to equation number 3, CO squared equals to R squared plus X squared. In the next step, we join points D and O together by a straight line. And we will implement the Pythagoras theorem on the right triangle FOD. On the right triangle FOD by PT TO squared equals to FO squared plus DF squared. Repeat again, in the right pink triangle FOD, according to the Pythagoras theorem, DO squared equals to FO squared plus DF squared. So DO squared equals to FO square. FO is R, so FO square is R square plus DF square. DF equals to 35, therefore DF square is 35 square. In conclusion, we found out that according to equation number 4, PO square equals to R square plus 35 square. So in the next step, I will copy the 4 equations that we derived from Pythagoras theorem in a new page. According to equation number 1, AO square equals to R square plus 33 square. According to equation number 2, BO square equals to R square plus 85 square. According to equation number 3, we found out that CO square equals to R square plus X square. And finally, according to equation number 4, we found out that DO square equals to R square plus 35 square. In the next step, I'll copy rectangle ABCD in a new page and also the circle that is inside the rectangle, and we'll analyze rectangle ABCD with its circle. So this is rectangle ABCD with circle inside it. We know that all the angles inside the rectangle are right angles, so this angle equals to 90 degrees. This size. This angle it is also equals to 90 degrees. This angle equals to 90 degrees, and finally this angle is equal to 90 degrees. the center of this circle is at point O. So from point O, we draw perpendicular on AB. And we extend the perpendicular towards DC. So here, this angle equals to 90 degrees, and this angle equals also to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB is T. Because of the fact that side AB is parallel to side DC, it means that the perpendicular from point A to AB must be also perpendicular to DC because AB is parallel to DC. Okay, so here this angle must be also equal to 90 degrees. And this angle must be also equal to 90 degrees. We define the touching point of the perpendicular from point O and DC is M. In the next step, we draw perpendicular from point O to BC. And we'll extend the perpendicular from point O towards AD. Again, this angle equals to 90 degrees, and this angle is also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as point L. Again, because of the fact that side BC is parallel to side AD, it means that the perpendicular from point O to BC must be also perpendicular to AD, because AD is parallel to BC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay. We define the touching point of the perpendicular from point O and AD as point H. So inside quadrangle edge OAT, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees plus the fourth angle. In total, it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this angle must be equal to 90 degrees, because 90 degrees plus 270 degrees is 360 degrees. That is the sum of the angles in any quadrangle. So in quadrangle ATHO, we have 4 right angles. Therefore, quadrangle ATHO is a rectangle. Likewise, in quadrangle ODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees, and therefore, quadrangle HODM is a rectangle. Likewise, in quadrangle TBOL, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore, quadrangle TBL O is a rectangle. And finally, in quadrangle OLMC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrangle OLCM is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. Okay, so in the next step, we'll define side AH as edge 1. We define side HD as edge 2. We define side AT as B1, and we define side TB as B2. So we have here 4 small rectangles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle AT edge O, AT equals to edge O. But we know that AT equals to B1, therefore edge O must be also equal to B1. Likewise, AH must be equal to TO according to the sum rule that the opposite sides of a rectangle are equal to each other. But we know that AH equals to edge 1, therefore TO must be also equal to edge 1. Likewise, the rectangle edge ODM, edge D equals to OM. But we know that edge D equals to edge 2, therefore OM must be also equal to edge 2. According to the sum rule, edge O must be equal to DM. But we know that DM equals to B1, therefore we know that edge O equals to B1, therefore DM must be also equal to B1. Likewise, the rectangle TBOL, TO must be equal to BL. But we know that TO equals to edge 1, therefore BL must be also equal to edge 1. According to the sum that the opposite sides of rectangle are equal to each other, we get that TB equals to OL. But we know that TB equals to B2, therefore OL must be also equal to B2. And finally, in rectangle OLMC, OM must be equal to LC. But we know that OM equals to H2, therefore LC must be also equal to H2. And also OL must be equal to MC according to the sum rule, but we know that OL equals to L2, but we know that OL equals to B2, therefore MC must be also equal to B2. In the next step, we will join points A and O together by a straight line. And we will implement the Pythagoras theorem on the right green triangle ATO. The right green triangle ATO. According to the Pythagoras theorem, AO squared equals to B1 square plus H1 square. Repeat again, in the right green triangle ATO, according to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Likewise, we join points B and O together by a straight line. We will focus on the right yellow triangle TBO. In the right yellow triangle TBO, according to the Pythagoras theorem, we will get that BO square equals to B2 square plus H1 square. Okay, again, in the right yellow triangle, according to the Pythagoras theorem, this BO square equals to B2 square plus H1 square. In the next step, we join point C and O together by a straight line. and focus on the right orange triangle CLO. The right orange triangle CLO. According to the Pythagoras theorem, we get that CO squared equals to B2 squared plus H2 squared. Repeat again, in the right orange triangle OCL, CO squared equals to B2 squared plus H2 squared. And finally, we'll join points D and O together by a straight line. And we'll implement the Pythagoras theorem on the right pink triangle DHO. The right pink triangle DHO. Yet, according to the Pythagoras theorem, that DO squared equals to B1 squared plus H2 squared. Repeat again. The right pink triangle DHO, according to the Pythagoras theorem, we get the DO squared equals to B1 squared plus H2 squared. So here we have two different expressions for AO squared, two different expressions for BO squared, two different expressions for CO squared, and two different expressions for DO squared. So we will create equation number, we will create four equations. Four new equations. Equation number 1 states that AO squared according to this equation number 1 must be equal to AO squared according to this equation number 2. So AO squared according to this equation number 1 is R squared plus 33 squared. And it must be equal to AO squared according to this equation number 2, that is actually B1 squared plus H1 squared. So according to the first equation, R squared plus 33 squared equals to B1 squared plus H1 squared. Then we create the second equation number 2, that states that BO squared according to equation number 1 must be equal to BO squared according to this equation number 2. So BO squared according to equation number 1 is R squared plus 85 squared. And it must be equal to BO squared according to this equation number 2, that is actually B2 squared plus H1 squared. So in conclusion, we found out that according to equation number 2, r squared plus 85 squared equals to b2 squared plus h1 squared. The next step, we create equation number 3 that states that co squared according to this equation number 1 must be equal to co squared according to equation number 2. So co squared according to equation number 1 is r squared plus x squared. And it must be equal to co squared according to this equation number 2, that is b2 squared plus h2 squared. So according to equation number 3, we found out that r squared plus x squared equals to b2 squared plus h2 squared. And finally, we create equation number 4 that states that dO squared according to equation number 1 must be equal to dO squared according to equation number 2. dO squared according to this equation number 1 is r squared plus 35 squared. And it must be equal to dO squared according to this equation number 2, that is actually b1 squared plus h2 squared. Repeat again, according to equation number 4, we found out that r squared plus 35 squared equals to b1 squared plus h2 squared. So we have here 4 equations. In the next step, we subtract equation number 1 from equation number 2. That is to say 2 minus 1. This way we'll create equation number 5. So according to equation number 5, we have here equation number 2 that states that r squared plus 85 squared minus equation number 1, we have here minus r squared plus 33 squared equals, in the other side of equation number 2, we have b2 squared plus h1 squared minus equation number 1, we have here minus b1 squared plus h1 squared. Okay, so we subtracted equation number 1 from equation number 2, we created here equation number 5. In the next step, we will open the brackets of this equation number 5. And we'll get that according to equation number 5, r squared plus 85 squared minus r squared minus 33 squared equals to b2 squared plus h1 squared minus b1 squared minus h1 squared. So here we have in this side of equation number 5 r squared minus r squared is 0, so r squared will get cancelled. In the other side of equation number 1, of equation number 5, we have h1 squared minus h1 squared is 0, so h1 squared will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? What is left? Here in this side of equation number 5, we left only with 85 squared minus 33 squared. In the other side of equation number 5, we left with b2 squared minus b1 squared. In conclusion, we found out that according to equation number 5, 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we'll subtract equation number 3 from equation number 4. So it is 4 minus 3. 4 minus 3. In this way, we'll create equation number 6. So according to equation number 6, we have here in this equation number 4, we have r squared plus 35 squared minus 3. Here in equation number 3, we have here r squared plus x squared. That is equal to the other side of equation number 4, we have b1 squared plus h2 squared minus equation number 3. On the other side, we have here minus b2 squared plus h2 squared. So in the next step, we'll open the brackets of this equation, equation number 6, and we get that according to equation number 6, r squared plus 35 squared minus r squared minus x squared equals to b1 squared plus h2 squared minus b2 squared minus h2 squared. So here in this side of equation number 6, we have r squared minus r squared, that is 0, so r squared will get cancelled. In the other side of equation number 6, we have h2 squared minus h2 squared, that is 0, so h2 squared will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? What is left is actually in this side of equation number 6, we left only with 35 squared minus x squared. That is equal to b1 squared minus b2 squared. In the next step, we'll multiply this equation number 6 by minus 1. And we get that according to equation number 6, minus x squared times minus 1 is plus x squared. 35 squared times minus 1 is minus 35 squared. And it is equal to minus b2 squared times minus 1 is plus b2 squared. And finally, b1 squared times minus 1 is minus b1 squared. So in conclusion, we found out that according to equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared. While according to equation number 5, we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. So we actually have two different expressions for b2 squared minus b1 squared. Therefore, we create equation number 7. According to equation number 7, so actually equation number 7 states that b2 squared minus b1 squared according to this equation, equation number 5 must be equal to b2 squared minus b1 squared according to this equation, equation number 6. So b2 squared minus b1 squared according to this equation, equation number 5, it is equal to 85 squared minus 33 squared. And it must be equal to b2 squared minus b1 squared according to this equation, equation number 6, that is actually x squared minus 35 squared. So found out that according to this equation, equation number 7, 85 squared minus 33 squared equals to x squared minus 35 squared. So here we'll add to this equation, equation number 7 35 square. And you get that according to this equation number 7, 85 square plus 35 square minus 33 square equals to x square. So here 85 square is 7,225 plus 35 square. 35 square is 1,225 minus 33 square. Minus 33 square is minus 1,089, that is equal to x square. So here 7,225 plus 1,225 is 8,450 minus 1,089, that is equal to x squared. Okay. So here 8,450 minus 1,089 equals to 7,361, that is equal to x squared. So actually, according to equation number 7, we found out that x squared equals to 7,361. Here we take a root out of this equation, equation number 7, and we get that according to equation number 7, x equals to plus minus square root of 7,361. So here we have two solutions that are possible for x. The positive square root of 7,361 and the negative square root of 7,361. But because of the fact that x is a length, x as a length, it must be a positive number. Therefore, we'll take into account only the positive solution of x. That is to say, here x is equals to the positive square root of 7,361. That is actually 85.796 units. So we actually found out that the line segment that we are looking for, that is x, equals to 85.796 units. So we finished with the first question. In the next step, I present to you the second question, and we will solve the second question in 3 different methods. In the drawing we have a semicircle. AB equals to 6 units. AB is actually the diameter of the semicircle that is equal to 6 units. We know that angle BAC equals to 30 degrees, and our mission is to find out the area of the green shape, or the value of the area of the green shape. Okay. We start with the first method. Here we will define the center of the semicircle as O. The diameter of this semicircle equals to 6 units according to what is given as the question. Therefore, the radius must be equal to half of it. That is to say, the radius equals to 6 over 2, that is 3 units. So OA, that is the radius of the semicircle, equals to 3 units. OB, that is also the radius of the semicircle, must be also equal to 3 units. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point on the semicircle itself. This is exactly the definition of radius. That is to say, CO is the radius of the semicircle, that is equal to 3 units. So, in triangle AOC, AO equals to OC, they are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, they are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. In triangle AOC, this angle equals to 30 degrees, this angle also equals to 30 degrees, 30 degrees plus 30 degrees is 60 degrees, and according to the rule that the sum of the angles in any triangle is equal to 180 degrees, the missing angle must be equal to 120 degrees. In the next step, I will present to you how to find out the area of any sector. So here we have sector A or B, that could be any sector. This is sector A or B. The lengths of the sector is AO and OB that are equal to R. They are both equal to the radii of the circle that contains the sector. The radius of the circle is R. And the angle between the legs of sector A or B is theta. What is the sign of a sector? Here, this is the rounded side, the rounded sign above the letters OAB is the sign for sector OAB. This means sector OAB. And therefore, the area of sector OAB will be this. This is the sign for the area of sector OAB. What is the area of sector OAB? It is equal to the area of the circle that contains the sector, that is to say pi r square, because r is the radius of the circle that contains the sector OAB, times theta. Theta is the angle between the legs of sector OAB over 360 degrees. So here, this ratio, theta over 360 degrees, gives us the relative percentage that this sector OAB occupies out of the entire area of the circle. And when we will multiply the relative percentage by the area of the entire circle, that is pi r square, we will get exactly the area of this sector, sector OAB. I'll repeat again. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle, that is actually pi r square. And then when we will multiply the relative percentage by the area of the entire circle, that is pi r square, we will get exactly the area of this sector, sector OAB. So the area of sector OAB, that could be any sector, is pi r square, that is the area of the circle that contains the sector, times theta over 360 degrees. And as I mentioned here a couple of times, that theta over 360 degrees is the ratio that gives us the relative percentage that this sector occupy out of the area of the entire circle. Okay, times the area of the entire circle, that is pi r squared, gives us exactly the area of this sector OAB. We'll use the new formula in order to find out the area of this sector AOC. So I copy sector AOC in this new page, and we will use the new formula in order to find out the area of this sector AOC. So this is actually sector AOC that I copied from the original drawing. Each leg of sector AOC equals to 3 units. It is actually the radius of the circle that contains, or the radius of the semicircle that contains this sector AOC. The angle between the legs of the sector, that is theta, equals to 120 degrees. Now you can easily find out the area of this sector AOC. According to the formula here, the area of this sector AOC will be equal to pi r squared, but r equals to 3 units. R is the radius of this semicircle, that is equal to 3 units. So if r is 3, it means that pi r squared will be equal to pi 3 squared times theta over 360 degrees. Theta is the angle between the legs of this sector AOC, that is 120 degrees over 360 degrees. Here 3 squared is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression will be equal to 9 pi over 3. 9 over 3 is 3. Therefore, in total, this expression will be equal to 3 pi. That is to say, we found out that the area of this sector AOC, equals to 3 pi square units. 3 pi square units. Okay. In the next step, I will present to you a new formula to find out the area of any triangle. And we'll use the new formula in order to find out the area of this triangle AOC. So here, if we have here triangle ABC, that could be any triangle. This is triangle ABC. And we know that the length of side AB is A units, side AC equals to B units in its length, and the angle between side AB and side AC in triangle ABC equals to theta. This is triangle ABC. So the area of this triangle ABC, according to the new formula, will be equal to A times B times sinus theta over 2. Repeat again, the area of this triangle ABC will be equal to A times B times sinus theta over 2. We'll use this formula in order to find out the area of triangle AOC. So I will copy triangle AOC here, and we'll use this formula in order to find out the area of triangle AOC. Actually, this is triangle AOC. This is a copy from the original drawing. According to the new formula, the area of this triangle AOC, will be equal to AO times OC times sinus 120 degrees over 2. Okay? AO is free, OC is also free. Sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so in total in the numerator we have 9 times square root of 3. In the denominator we have 2 times 2, that is 4. In conclusion, we found out that the area of this triangle AOC equals to 9 times square root of 3 over 4 square units. So I write it down. We found out that the area of this triangle AOC equals to 9 times square root of 3 over 4 square units. And again, the area of this triangle AOC equals to 9 times square root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? For the moment it is very easy to see that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. The area of sector AOC minus the area of triangle AOC equals exactly to the area of the green shape. I repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So we found out that the area of the green shape, in conclusion, equals to 3 pi, to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers it is equal to 5.53 square units. We finished with the first method. The next step I'll present to you how to find out the area of this ring shape according to the second method. According to the second method, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of triangle COB according to the second method. It's very simple to see it from the drawing that the area of the semicircle minus the area of triangle AOC minus the area of sector COB will give us exactly the area of the green shape. So what is the area of the semicircle? The area of the semicircle is equal to pi r squared over 2, the area of the circle over 2. We have already found out that the radius of this semicircle is r equals to 3, so pi r squared over 2 is pi times 3 squared over 2. 3 squared is 9. So in total, this expression will be equal to 9 pi over 2. So in conclusion, we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to do in order to find out the area of the green shape is to find out the area of sector COB. What is the area of sector COB? First of all, we have to find out the angle between the legs of sector COB. AB is the diameter of the semicircle, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line AB at point O, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, we get that on the upper side of AB at point O, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. So 120 degrees plus the missing angle must be equal to 180 degrees. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. Now I'll copy sector COB in a new page and we'll find out the area of this sector COB according to the new formula. Okay. So this is sector COB that is copied from the original drawing. You know that according to the new formula, the area of any sector equals to pi r squared times theta over 360 degrees. Use this formula in order to find out the area of the sector COB. According to this formula, the area of sector COB be equal to pi r square. R is 3, therefore pi r square is pi 3 square. Theta is the angle between the legs of sector COB, that is 60 degrees, so it is 60 degrees over 360 degrees. Okay. So here 3 square is 9. So actually this expression equals to 9 pi, and 60 degrees over 360 degrees is 1 over 6, so in total this expression will be equal to 9 pi over 6. Here we will divide both the numerator and the denominator by 3. 9 over 3 is 3, so in the numerator in total we have 3 pi. 6 over 3 is 2. So in conclusion, we found out that the area of this sector COB, equals to 3 pi over 2 square units. Now we can find out the area of the green shape. I repeat again, the area of the green shape, according to the second method, equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I repeat again, according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of triangle COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units minus the area of triangle AOC. We already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units, and finally we have already found out that the area of sector COB equals to 3 pi over 2 square units. Here 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2. So we have 6 pi over 2 minus 9 times square root of 3 over 4 square units. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4. In conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. We finished with the second method and with the second question. In the next step I will summarize the lecture. I'll start with the first question. in the drawing we have rectangle ABCD. Inside rectangle ABCD we have this circle, and we know that the tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle is unknown. That is the tangent that we are looking for. So we have to find out the value of x. So the length of this tangent is x. And finally the length of the tangent from point D to this circle is 35 units. Again, our mission is to find out the length of the tangent from point C to this circle, that is to find out the length of line segment CH, that is equal to x according to what is given as the question. So, first of all, we define the center of this circle as O, and we have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Then we have the radius OH that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. We have the radius OT that is drawn to the point of tendency, therefore this angle equals to 90 degrees. And we have the radius OE that is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. Then we joined points O and A together by a straight line. In this way, created the green right triangle AOE. The green right triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus EA square. AE square. Okay, again in the green right triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. A equals to 33, O equals to R. So AO square equals to OE square. OE is R, so OE square is R square plus A square. A is 33, therefore A square is 33 square. So according to equation number 1, we found out that AO square equals to R square plus 33 square. Then we joined points O and B together by a straight line. In this way we created the yellow right triangle OTB. The yellow right triangle OTB, according to the Pythagoras theorem, OB square equals to OT square plus TB square. Repeat again, according to the Pythagoras theorem, the yellow right triangle, PO square equals to OT square plus TB square. OT equals to R and TB equals to 85. So OT is R, therefore OT square is R square, TB is 85, therefore TB square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. Then we joined points C and O together by a straight line. This way we created the orange triangle, the orange right triangle, triangle OHC. According to the Pythagoras theorem, OC square equals to OH square plus HC square. OCO square equals to CO square equals to HO square plus H is equal to HO square plus HC square. Yeah, HO square plus HC square. Again, CO square equals to HO square plus HC square. Okay. O edge or edge O equals to R and HC equals to X. Therefore, HO equals to R, therefore HO square is R square. HC equals to X, therefore HC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. And finally, we joined points D and O together by a straight line. In this way, we created the pink right triangle AOD. The pink right triangle AOD, FOD, according to the Pythagoras theorem, DO square equals to FO square plus FD square. Again, the pink right triangle FOD, DO square equals to FO square plus DF square. Here, the FO equals to R, FD equals to 35. FO equals to R, therefore FO square is R square, DF equals to 35, therefore DF square is 35 square. So in conclusion, we found out that according to equation number 4, DO square equals to R square plus 35 square. So candidate 4 questions that derived from the Pythagoras theorem. So I copied those 4 questions in a new page, and then I copied rectangle ABCD with circle inside in this new page. We know that all the angles inside the rectangle are right angles, so those 4 angles are all right angles. The center of this circle is point O. From the center of this circle, we draw perpendicular on AB. Again, from the center of this circle, that is to say from point O, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. Okay, we define the touching point of the perpendicular from point O and AB is T. Because of the fact that side AB is parallel to side DC, it means that the perpendicular to AB from point O must be also perpendicular to DC. Again, why? Because AB is parallel to DC. So here, this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees. Likewise, from point O, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. But because of the fact that side AD is parallel to side BC, it means that the perpendicular from point O to BC must be also perpendicular to AD. So this angle must be equal to 90 degrees, and this angle must be also equal to 90 degrees. So in quadrilateral AT edge O, we have 1, 2 right angles. The fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So 230 degrees plus 90 degrees, that is 360 degrees, that is the sum of the angles in any quadrilateral. Quadrilateral AT edge O has 4 right angles, therefore quadrilateral AT edge O is a rectangle. Likewise, in quadrilateral edge ODM, we have 1, 2, 3 right angles. Therefore, this fourth angle must be also equal to 90 degrees. Therefore, quadrilateral edge ODM is a rectangle. Likewise, in quadrilateral TBOL, we have 1, 2, 3 right angles. Therefore, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. Therefore, quadrilateral TBLO is a rectangle. And finally, quadrilateral OLMC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrilateral SMOL is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. Then we define side AH as H1, we define side HD as H2, we define side AT as B1, and side TB as B2. We know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle AT edge O, side AT must be equal to side edge O, but we know that AT equals to B1, therefore edge O must be also equal to B1. According to the symbol, AH equals to TO, but we know that AH equals to H1, therefore TO must be also equal to H1. Likewise, in rectangle HODM, HO must be equal to DM, but we know that HO equals to B1, therefore DM must be also equal to B1. According to the symbol, HD equals to OM, but we know that HD equals to H2, therefore OM must be also equal to H2. In rectangle TBOL, TB equals to OL, but we know that TB equals to B2, therefore OL must be also equal to B2. Likewise, TO must be equal to BL, but we know that TO equals to H1, therefore BL must be also equal to H1. In rectangle OL, MC, OL must be equal to MC, but we know that OL equals to B2, therefore MC must be also equal to B2. Finally, OM must be equal to LC, but we know that OM equals to H2, therefore MC must be also equal to H2. Then we join points A and O together by a straight line. We implemented the Pythagoras theorem on the right green triangle ATO. According to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Repeat again. In the right green triangle ATO, AO square equals to B1 square plus H1 square. Then we joined points B and O together by straight line. We implemented the Pythagoras theorem in the right yellow triangle TBO. In the right yellow triangle, according to the Pythagoras theorem, or BO square equals to B2 square plus H1 square. And again, in the right yellow triangle, BO square equals to B2 square plus H1 square. Then we joined points C and O together by straight line. Implemented the Pythagoras theorem on the right orange triangle CLO. According to the Pythagoras theorem, CO square equals to B2 square plus H2 square. Repeat again, the orange right triangle CO square equals to B2 square plus H2 square. And finally, we joined points D and O together by straight line and implemented the Pythagoras theorem in the right pink triangle HOD. According to the Pythagoras theorem, DO square equals to B1 square plus H2 square. Again, in the right pink triangle, DO square equals to B1 square plus H2 square. So we have two different expressions for AO square, two different expressions for BO square, two different expressions for CO square, and two different expressions for DO square. Now we have created four more equations. According to equation number 1, AO square according to this expression must be equal to AO square according to this expression. Okay. Then we created the equation number 2 that states that BO square according to this expression must be equal to BO square according to this expression. Then we created the equation number 3 that states that CO square according to this expression must be equal to CO square according to this expression. And finally we created the equation number 4 that states that DO square according to this expression must be equal to DO square according to this expression. So those are the four equations that we created. Then we subtracted equation number 1 from equation number 2. That is to say 2 minus 1. So here what we have in equation number 2, we have here r square plus 85 square minus equation number 1. In equation number 1 we have r square plus 33 square. That is equal, then in the other side of equation number 2 we have b2 square plus h1 square minus equation number 1 we have here b1 square plus h1 square. Okay. Equation number 5 states that it's actually 2 minus 1. Okay, equation number 5 is 2 minus 1. Equation number 2 minus equation number 1. Okay, then we open the brackets on this equation number 5 and found out that according to this equation number 5, r square plus 85 square minus r square minus 33 square equals to b2 square plus h1 square minus b1 square minus h1 square. Here r square minus r square is 0, so r square we can cancel it. In the other side of equation number 5 we have h1 square minus h1 square is 0, So what is left from equation number 5 after we cancel those two expressions? What is left is that 85 square minus 33 square equals to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. That is to say, 4 minus 3. What we have in equation number 4, we have here r square plus 35 square minus equation number 3, we have here r square plus x square. In the other side of equation number 4, we have b1 square plus h2 square minus equation number 3, we have here b2 square plus h2 square. Okay. Then we open the brackets of this equation number 6, and we found out that r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. Here r square minus r square is 0, so r square will get cancelled. In the other side of equation number 6, we have h2 square minus h2 square is 0, so h2 square will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? In this side of equation number 6, we have left only 35 square minus x square, that is equal to b1 square minus b2 square. Here we multiply this equation number 6 by minus 1, and we got that minus x square times minus 1 is plus x square, 35 square times minus 1 is minus 35 square, minus b square times minus 1 is plus b2 square, and minus, here we have b1 square times minus 1 is minus b1 square. So according to equation number 6, we found out in conclusion that x square minus 35 square equals to b square minus b2 square. According to equation number 5, we found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b2 square minus b1 square according to this equation number 5 must be equal to b2 square minus b1 square according to this equation number 6. Again, equation number 7 that states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. That is to say, according to equation number 7, we found out that 85 square minus 33 square equals to x square minus 35 square. We added 35 square to this equation number 7, and found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225, 35 square is 1,225, minus 33 square, minus 33 square is 1,089. That is equal to x square. 7,425 plus 1,225 equals to 8,450 minus 1,089, that is equal to x square. 8,450 minus 1,089 equals to x square. 8,150 minus 1,089 is equal to 7,361, is equal to x square. So according to equation number 7, we found out that x square equals to 7,361. Then we took out of this equation number 7, we found out that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, the positive solution and the negative solution. But because of the fact that x is a length, as x as a length must be a positive number, so we take into account only the positive solution. That is to say, the answer to the question is that x equals to 85.796 units. So the line segment that we are looking for, that is to say x equals to 85.796 units. We finish the first question, then I presented to you the second question, and we solved the second question in two different methods. In the drawing we have a semicircle. We know that angle BAC equals to 30 degrees, AB equals to 6 units. AB is the diameter of this semicircle, that is equal to 6 units. So our mission is to find out the area of the green shape. We define the center of this semicircle as O. We know that the diameter AB of this semicircle is 6 units, therefore the radius must be equal to half of it. That is to say, the radius must be equal to 6 over 2, that is 3 units. So OA, that is the radius, equals to 3 units. BO, that is also the radius, it is also equals to 3 units. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of this semicircle, that is equal to 3 units. So in triangle AOC, those two sides are both equal to 3 units, therefore they are equal to each other. We have the rule that in front of equal sides in the triangle are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, this angle equals to 30 degrees, this angle also equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees. This is the sum of the, so we have here inside triangle AOC, the sum of those two angles is 60 degrees. So plus the sum of the third angle, in total they must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. So the missing angle must be equal to 120 degrees. Then I presented to you a new formula for the area of any sector. This is sector A or B, that could be any sector. AO equals to OB, they are both the radii of the circle that contains this sector. And the radius of the circle is R. And the angle between the legs of the sector, AOB, is theta. So the area of this sector, sector AOB, equals to pi r square, that is the area of the entire circle, times theta over 360 degrees. I'll explain you what is the meaning of this formula. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire of the area of the entire circle. Again, theta, ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle. And then when we will multiply the relative percentage that this sector occupies out of the entire area of the circle, and when we will multiply it by the area of the entire circle, that is pi r square, we'll get exactly the area of this sector AOB. Again, the relative percentage that this sector occupies out of the area of the entire circle is theta over 360 degrees. And then when we will multiply the relative percentage by the area of the entire circle, that is pi r square, we get exactly the area of this sector, sector AOB. So the area of this sector AOB equals to pi r square times theta over 360 degrees. We use this formula in order to find out the area of sector AOC. So I copy sector AOC here. AO equals to OC, they are both the radii of the semicircle, that is equal to 3 units. The angle between the legs of sector AOC equals to 120 degrees. So you can see here. So according to the new formula, the area of the sector AOC will be equal to pi r square. R is 3, so pi r square is pi 3 square. Theta is 120 degrees. So it is 120 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3. Because here 120 degrees over 360 degrees is 1/3. Again, this expression in total equals to 9 pi over 3. 9 over 3 is 3. So in total this expression equals to 3 pi. So in conclusion, found that the area of this sector AOC equals to 3 pi square units. Then I presented to you in your formula to find out the area of any triangle. Here we have triangle ABC that could be any triangle. And this triangle ABC. The length of side AB is the units, the length of side AC is units, and the angle between side AB and side AC is theta. Then the area of this triangle ABC equals to A times B times sinus theta over 2. Again, the area of this triangle ABC according to the formula equals to A times B times sinus theta over 2. We use this formula in order to find out the area of this triangle AOC. So I copy triangle AOC here and use this formula in order to find out the area of this triangle AOC. AO equals to 3, OC equals to 3, and the angle between AO and OC is 120 degrees. So according to the formula, the area of this triangle AOC equals to AO times OC times sinus 120 degrees over 2. Okay. AO is 3, OC is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so in total in the numerator we have 9 times square root of 3, and in the denominator we have 2 times 2, that is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And again, we found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? From the domain it is very easy to see that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will give us exactly the area of this green shape. Repeat again, the area of sector AOC according to the first method equals to the area of sector AOC minus the area of triangle AOC. But we have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC, that is equal to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. Okay. To finish with the first method, then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Again, the area of the semicircle minus the area of triangle AOC minus the area of sector COB will give us exactly the area of this green shape. I repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out what is the area of the semicircle. The area of the semicircle equals to the area of the circle over 2, that is to say it is equal to pi r square over 2. R equals to 3, so it is pi 3 square over 2. 3 square is 9, so in the numerator we have 9 pi over 2. So in conclusion, we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to do in order to find out the area of this green shape according to the second method is to find out the area of sector COB. In order to find out the area of sector COB, we have to find out the angle between the legs of sector COB. AB is a diameter of the semicircle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line OB at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have in the upper side of AB at point O, we have this angle that is equal to 120 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. Okay? So the angle between the legs of sector B or C equals to 60 degrees. So I copy sector B or C in the new page and we use the new formula in order to find out the area of this sector B or C. The angle between the legs of this sector B or C is 60 degrees. CO and BO are both the radii of the semicircle, that is equal to 3 units. They are also the legs of the sector. So according to the new formula, the area of any sector equals to pi r square, that is the area of the circle that contains the sector, times theta over 360 degrees. Theta is the angle between the legs of the sector. In this case, it's 60 degrees. Here r equals to 3, and again theta equals to 60 degrees, so pi r square is pi 3 square. Theta is 60 degrees, so it is 60 degrees over 360 degrees. 3 square is 9, so total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. In total, this expression equals to 9 pi over 6. We divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2. So I found out that the area of sector COB equals to 3 pi over 2 square units. Now we can find out the area of the green shape according to the second method. I will remind you that according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And we just right now found out that the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2. So here we have 6 pi over 2 minus 9 times 4 to 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So it is 3 pi minus 9 times 4 to 3 over 4. So in conclusion, we found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times 4 to 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, thank you very much.